Hello student, myself Dada Pires from Government Degree College Chenigiri. Today in this session we discuss about the Fresnel theory of the optical activity. As you know that optical activity is the phenomena in which it rotates the plane of polarization. So this is the such phenomena, and he explained, and this was by the Fresnel. So he was successfully explained this optical activity. So in this explanation, he was think that when when a plane polarized light is passed through some crystal along the optic axis, so it splits into two circular polarized vibrations rotating in opposite directions with the have a same frequency, and amplitude is half of the incident one. It is the assumption he was doing. So when light is passed through that crystals, it splits into two circularly polarized vibration rotating in opposite direction. They have same frequency and amplitude is half of it, and the resultant and follow the resultant path of this circular polarizer. Because of the two circular polarizer, they follow the resultant path depend upon their velocities, and the substances we use. If it is optical active, it is different. Optical inactive, it is different. So let's we see how this will be explained. So then the velocity of the component waves are same in the optical inactive crystal. When the optical inactive crystal is there, their velocity will be same. So whereas some in optical active crystals, then the velocity is different. So they move with the different. So in keeping in this mind, he just keep the optically inactive crystal, that is calcite crystal. He's taking calcite crystal, he passed through the plane polarization, right? It splits into two circularly polarized lights, and they produce vibrations. They have moved forward with the same speed. It is because in optical inactive one. So then the part of the face OL have component of the circular polarized vector rotating to the left, that is anti-clockwise, and component OR to the right one, that is move towards like clockwise direction. So and that resultant vibrations of the vector will be the along OA. They move OL anti-clockwise and OR is clockwise, and the resultant motion is along the OA. So in this way, the emergent light which is coming resultant of these two light then is not rotate in the calcite crystal. It does not rotate in the calcite crystal. They follow the resultant path. So whereas in optically active crystal is taken, for example, if you take the quartz, so what happened, the two component circular polarized vibration move forward with slightly different velocities. They move with some different velocity we see in that. So one content will be move faster than the another component. So in this way they have a there is some path difference is arises between them. So this leads to one follow speed, and in case of this quartz crystal, the velocity of clockwise rotation is more than the anti-clockwise rotation. They follow clockwise direction is how more than the anti-clockwise rotation. So it is exactly opposite to the left hand quartz crystal. That is left hand quartz crystal. This is the Leo rotatory. It's just exactly opposite to that of the left-handed quartz crystals. This is in optical electric crystals. So when this you take dextrorotatory quartz crystal, consider dextrorotatory quartz crystal, the resultant of clockwise rotations like OR and anti-clockwise rotation OL will be the resultant path will be the OA dash. So resultant path is not OA along, it does not follow along this way. They follow this, it does not follow. They follow the resultant path in this way. So it can be follow because of their difference in their velocities. So they rotate some angle, that is pi, some angle. So on passing the angle of rotational plane of vibration by pi by 2, each have a pi by 2 rotation angle, and they depend upon the thickness of the crystal on which a plane polarization line passes through, such a to rotate this. How can we, let's see, give the analytical treatment. Let's see, show in the theories. First we take inactive, optically inactive crystal, that is according to this special theory, the circular polarity is the resultant of the two rectangular simple harmonic motion. The two circular harmonic motions, the resultant effect will be studying here after passing through this calcite crystal. So optically, like calcite crystal, when we light is passed through, they will create two circularly polarized light. One is clockwise direction, another one is anti-clockwise direction. So clockwise direction is given by this relation. Let you consider, along x-axis is x1 a cos omega t, and along y-axis is sin omega t, a sin omega t. For along y-axis, x-axis is a cos omega t. And for the anti-clockwise direction, if you take anti-clockwise direction, so then x2 is given by minus cos omega t because of the negative sign, so it's minus cos omega t, and y2 along y-axis is sin omega t. So where here is the a is used as an amplitude, and omega 2 is the phase, initial phase. Omega t is the initial phase of this one. When this resultant motion, let me see their resultant motions along the x-axis and y-axis. First calculate the for x-axis, that is the resultant motion capital X is equal to x1 plus x2 is sum of these two. A cos omega t is x1 minus a cos omega t is the x2. When you add this, it gives the 0. There is no resultant motions. So resultant along y-axis, there is y1 and y2, a equal to sin omega t and a equal to sin omega t. Then it can be add up and gives the 2a sin omega t. So here is we see that the amplitude rises the twice of the both the waves. So this the plane polarized light is there. So the resultant vibration is along the original direction is plane polarized. And 2a is the twice that of the component of waves. Because of the adding up, the amplitude is rises by 2 times, means they are add up. When you use optically active crystals, when you apply for this theory for optical active crystals, taking as a dextrorotatory optical active crystal like quartz, then the clockwise vibration travel faster than the anti-clockwise vibrations, and this clockwise vibration starts from R and anti-clockwise starts from L. So and the phase difference is created between this because of their speed varies, means velocity varies, hence they follow the phase difference. One is go fast, another one is slow, so that there is a created, the resultant motion create the phase between them. So then for the clockwise direction, so there is a clockwise direction and can be given by the term x1 is equal to a cos omega t minus pi. There is a phase difference, so it crosses the pi, and y1 is a sin omega t minus pi, where pi is the negative and it is measured in clockwise direction. So for if you take for anti-clockwise vibrations, then x2 equal to minus a cos omega t usually, and y2 is equal to a sin omega t. A is the amplitude, omega t is the phase. Combining resultant effects, after we seeing this resultant effect, the resultant along the x-axis is given by x is equal to x1 plus x2. So then resultant effect, say x1 is a cos omega t plus and yx2 is a cos omega t. So there is this answer A is common, taken A outside, and cos A minus cos B value is given by 2 sin pi by 2 and 2 sin omega t pi by 2 cos B. So on this resultant along the y-axis, if you take for the resultant along y-axis, so y is equal to y1 plus and y2. Put this value under y1 a sin omega t minus pi and sin omega t, and this value is given by 2a cos a by 2 and c omega 2 minus pi by 2. This is the resultant effects. When these two effects along the y-axis is y1 plus y2 usually, and given cos omega 2. So resultant vibration along x and y perpendicular to one another. In the same phase, the resultant vibration x and y is thus plane polarized. Dividing this x by y gives the tan pi by 2. So there is the path difference of pi will be seen here. So from this equation, that is dividing x by y is equal to tan pi by 2, that is resultant emergent plane polarized light is inclined at an angle of pi by 2 to the virginal direction. So it is in optically active. So and there the plane of polarization is rotated through a pi by 2 on passing through the crystal and is dependent on the thickness passing through the optically active crystals. So it's dependent on the thickness of the crystal, and also it depends upon the thickness of the crystal. Hence from this result we can calculate and how much it rotates. Let's we calculate the angle of rotations. If you take their refractive index of the both left-hand and right-handed rotative polarized vibrations, the NL and NR be the refractive indices of the quartz crystal along the optic axis of circularly polarized anti-clockwise and unclockwise direction respectively. If the D is the thickness of the crystal and lambda is the wavelength of the incident light, and then the path difference of the two vibrations is given by, that is del is equal to NL refractive index differences into their thickness D. So but path difference is given by 2 pi by lambda into path difference, that is path difference is del, that is 2 pi by lambda into NL minus NR, the difference in the refractive index into the thickness. Further, the value of NL and divided by 2, this is the pi value, and put this value divided by 2 means 2 pi goes cancel, 2 is cancel, that is pi by lambda is remain, NL minus NR into D will be available for this. Here the NL and if the consider NL refractive index in terms of the velocities, VL and VR the velocity of the left-handed and right-handed circularly polarized vibrations, and then we take refractive index NL, left-handed is given by C by VL and right-handed refractive index is C by VR and VL is the velocities, C is the velocity of light. In terms of we convert the velocity refractive index into velocities. So there we taken refractive index NL is equal to C by V in the form. So on this equation, that above equation can be write down pi by 2 is equal to pi by lambda, NL can be converted into C by VL and R can be differences under C by R into D. So there is the difference is there, the difference term is there, difference term is decides whether they are which one is higher value and which one velocity is higher or less value or equal. When they are equal, what happen, let's we see in the next slide. So then we take C, take common outside, take C as common to the outside, that is pi C by lambda 1 by VL difference of 1 by vr is equal to dr is equal to pi by 2. So this is the for the pi by 2 value. So some value, we know that constant value is the product of their frequency and wavelength, and frequency can be given by reciprocal of period, that is 1 by t, that is c equal to lambda t. Put this value in this previous equation, that is we can be say that pi by 2 is equal to pi c value changes, lambda lambda get cancelled, that is pi by t into 1 by vl minus 1 by vr into thickness, that is d. Let me consider for some cases for left-handed, right-handed, when they are optically inactive. So these are the three cases we have studied this equation. So that's the first. In the case of left-handed substances, the refractive index VL is greater than the velocity of the left-handed is greater than the right-handed. So it take the equation, the above equation can be changes slightly, that is mu r minus, that is nu r minus nl, means refractive index differences pi d by lambda c, that is nr. Then if you apply for this 1 by pi d by t, that is 1 by vr minus 1 by l, just value is vl is greater than, so its value become, this value become less, this value become higher, that is, so it's exchange this value only. So 1 by vr minus 1 by vr, there is no difference symbol, here is the minus, because its value less, it gives the larger value. This is pi d by t into difference of this one value. So for the right handed, if you think for the right handed, the velocity of the uh, right-handed vibrations are greater than the left-handed vibrations. So vr is greater than vl, so just equation changes by 1 by uh, l changes 1 by vl minus 1 by vr. So in case imagine the second case is over. For third case, if it is to take the optically inactive substance like calcite, so what's happened, their velocity vr and vl are equal, vr and vl equal, means this gives the value is 0 vr. So then their pi by 2 is nothing but 0 when vl and vr equal. So what this term tends to 0, so 0 into anything is 0, that is pi by 2 is 0, then they does not follow the deviation, they follow the resultant motions of the two rays, it follows the two resultant motions. So from this equation we got this one. So if it is optically inactive, then their light does not deviate, no one have move more velocity, they have equal velocity and move in the straight line, means resultant motion along OA as we see in the first case. So this is about the Fresnel theory of the optical active axis, how this theory, when in optically active how they behave, when in optical inactive the velocities of two motion circular motions are equal, so then their resultant motions follow the center path. If there are three motions, there two motions are there, left and right, left and right, so then resultant motion will be in the center, because of they have both have travel equal velocity, they follow the center one. So after this one, if there are some, this is in optically inactive, we proved that velocity are equal, hence they are follow the center path, they have the center path. If the velocity is more, they slightly different, that is pi d by lambda is equal to 1 by vl minus 1 by vr, or 1 by vr minus 1 by vl, depend upon their speed. So this is going to be happen, that is proved by the Fresnel. That is how they are related, how this optically active rotate the plane polarized. This he was explained, and also due to the rotation he was doing a experiment to show that he take the two optically quartz crystal and make it to be a just opposite to each other. They formed a circular into plane polarized light and plane polarized into circularly polarized light. So similarly he was doing it. So hence he proved that one they have a optically active substance, how they behave in optically inactive crystal and optically active crystal, how the resultant path will